Okay, so let's take some examples of open balls. One, let us take x, comma, d naught. Let this be the discrete metric space. We have studied what this means. Okay. Precisely, we want to take x to be the set of real numbers. And then I want to remind us of what d naught is. So d naught of x, comma, y, by definition is 1 if x is different from y, and it is 0 if x is equal to y. Now, for any point, precisely, let's start from small, so let's take x naught to be any real number of our choice. Let me take it to be 2, and we take r to be, say, 1 and 4. Notice that 1 and 4 is a positive number, so it qualifies to be our radius. Our goal here is to compute, we want to compute the open ball with center x naught and radius r. Okay. By definition, the open ball with center x naught and radius r is the collection of all y in capital X such that the distance between y and x naught is strictly smaller than r. Now we substitute what our capital X is, what our x naught is, and what our r is. And so this is the collection of all y in the set of real numbers, such that the distance between y and our x naught is 2 is strictly less than 1 on 4. This is what we have, just by applying definition. The next thing we have to ask ourselves is this. How is d naught defined? This is how it is defined. It gives only 2 values. So for any 2 elements in it, so for x, y, you give the image of this function on this particular element is either 1 or it is 0. And so if we use that, we see that here, the distance between, that means d naught of y comma 2 is already smaller than 1 over 4. And 1 over 4 is less than 1, this one standing here. Therefore, this is the collection of all y in R such that d naught of y comma 2 is equal to 0. Because this man can only give us 2 values. We have ruled out the possibility of giving us 1 because this restricts this from being more than 1 over 4. And so since it's not up to 1 over 4 even, it cannot be equal to 1. And so the element, the value to give us is 0. And that is why I'm right that this is all y in R such that d naught of y comma 2 is equal to 0. Alright. Now by definition of d naught again, d naught of x comma y is 0 implies that x is equal to y. Our y in this case is 2. So this is nothing but all y in R such that y is equal to 2. But then, this is nothing but a singleton set because there is no other real number that is 2 apart from 2 itself. So this set is nothing but a singleton 2. And therefore, the open ball with center 2 and radius 1 over 4 is exactly the singleton set 2. Let us still using the discrete metric. Let's again take x comma d naught to be the set of real numbers comma D naught, where D naught is as we defined before. Now, let us take our x naught to be still 2, but now we change the radius. So we take R to be, say, 3. Okay. Our goal is to compute the open ball with center x naught and radius R. Solution. From definition, B x naught R is the collection of all y in the set of real numbers. In fact, let me change this so that you don't get used to y, be as if it must be y. So let me change and take w. So you know that these are just w variables. So this is the collection of all elements, I call it w in R, such that the distance between w and x naught is strictly smaller than R. This is nothing but all w in R such that d naught of w, our x naught is who? It is 2. Is strictly less than our R is who? It is 3. Good. This is what we have. Now, here comes the question. We must take into account the behavior of D naught. D naught produces only 2 images, 1 and 0. Okay, so here we have that this, by definition, is equal to this. So this is again equal to all W in R such that, look, the distance D naught between W and 2 is strictly smaller than 1. And we know that this distance can only give us 2 values, 1 or 0. So if it gives us 1, 1 is less than 3. If it gives us 0, 0 is less than 3 also. Therefore, the 2 possibilities we can get. So we can write this as the collection of all W in R such that D naught of W, 2 is equal to 1 or it is equal to 0. Because if it is 1, it's achievable because it's smaller than 3, like I explained. If it is 0, it is also possible because 0 is smaller than 3. Alright. From here, we know that in set theory, all means union of 2 sets. So we break this into 2 sets. Collection of W in R such that D naught of W, 2 is 1, union the collection of W in R such that D naught of W, 2 is equal to 0. Now, if D naught of W, 2 is 1, what does it mean? This is all W in R such that this is equal to, it means that W is exactly not equal to 2. Because by definition, look, don't forget that we define, just please permit me to write this, that D naught of x, y is 1 if x is different from y, and it is 0 if x is equal to y. So this is what we are using to make this judgment. And so if this is equal to 1, it means x is not y, our x is w, our y is 2, and so we can have this. And again, union. Please, I'm writing this for the sake of emphasis. So union, all W in R such that W is equal to 2. This again is the same as, so all W in R that are not equal to 2 is nothing but the set of real numbers without the singleton 2. Union, all real numbers that are equal to 2 is nothing but the singleton 2. So at the end of the day, R without 2 union 2, union the singleton 2 gives us the whole of R.